like a local.
Nice.
Yeah, I don't have GM.
So hi, I'm Mark, and today we'll be talking about making games multiplayer. This is a guide to understanding Godot's multiplayer. I go by Bear Like Lion online, and you can head to the next slide. So hi, I'm Mark. I'm a full-stack and independent game developer. I write C++, C#, Java, JavaScript, Godot, Python. Next. I have 2 games on Steam, SurfsUp 2025 and Survivalscape 2024. SurfsUp was developed with multiplayer from the start, but Survivalscape I added multiplayer in last month for this talk. It is way different to build it with it in mind, to add it after the fact. I have 24 games on itch.io. I've made 11 in the last year, 9 of which feature different forms of multiplayer. And I've contributed multiple fixes to Godot Steam and Godot's Steam multiplayer peer. So I have a booth in the back right of the garage. It has 15 different projects you can come check out and play. It is a Godot game of Godot games. You launch, you play whatever. When you quit, it gives you a small little thing for feedback. Hopefully it's in this video here. Hey, feedback, you got a minute? Tell me what you thought of it. All of this is open source. It's all on GitHub. There's a QR code to my Connect page that has a little shout box, and go crazy with it. Today we'll be talking about Cooties. It is an open source multiplayer game of tag where one player gets Cooties and spreads it to the others. It's based on 5 rounds. Whoever has the highest rep score about not being infected is the winner. It's built entirely with Godot's high-level multiplayer, and I developed it in a single 16-hour sprint without any AI or agentic coding. So it's already spreading. Do we have audio? So it's fine. This is Covino. Covino's here. Oh, there we go.
There he is. Wait.
So using this netcode, this example, I highly suggest, please play with it, get into it, learn it a bit, right? So we can go to the next page. And the one thing I really enjoyed was a friend of mine reached out. He was doing a paid Godot contract. And can you hit the button for me? He sent me an image of the entire Cooties source code was in this project and referenced for them to try to add multiplayer later. It really made me feel incredible. Like, I love that people are using it and going crazy with it. All right, next slide. So today we're going to cover establishing a connection, who is who, the difference between peer ID and Steam ID, RPCs, or how we can politely yell functions across the internet, spawning and setting authority, and staying in sync with other players. So to start, every time I am in a Godot project, I immediately look at the autoloads. It's the most important bit. It runs everywhere. In Cooties, we have 2 autoloads. The global, which is the source of truth for everything, where we're changing levels, and the Steam init, which is how we handle our Steam connection to run callbacks. My pro tip is use folder colors. If you right-click, you can set a folder color. It makes it really easy when you're in big projects to know what you're working in. So scene switching. We have one scene to rule them all. We have a main scene that has a level node that instantiates our level. Now, there is a level spawner node to keep everyone in sync. Can you hit that for me? So instead of switching scenes, we're swapping children. This way, hit it for me. The big issue with change scene to file is that it tears down the entire tree. If there's any network latency, you can have stuff break mid-swap. It's unreliable for multiplayer. The main scene never dies. It exists on every peer, and every frame the swap arrives as a call local RPC. So we're going to establish a connection. We're going to talk about the strength of Godot's multiplayer peer. So one of my favorite features of multiplayer is the multiplayer peer class. The power of it is you can swap out any sort of backend and keep the same high-level architecture. So we're going to go over eNet multiplayer peer, which is IP import. It ships with Godot, works on every platform, but you have to handle the networking. Next, Steam, which uses the Godot Steam extension, has lobbies, relays, friends. You never have to see or expose an IP. And additionally, there's things like Nakama, the Epic Online service for Godot, and the offline multiplayer peer, allowing your multiplayer game to work as a single-player game. You can change the connection and keep the same code. Comparing eNet and Steam, eNet requires you to forward a port, send your IP to a friend, but it runs everywhere Godot can run. It is great for prototyping or testing locally on one machine. With Steam, it automatically traverses the NAT, lobbies are built in, it's free besides what you're paying to Valve, and it's Steam only. It's great for release games and Space War. In most of my production games, I run both. So I can test eNet locally, play with myself, or Steam to play with a friend. So we're going to let the player pick how to connect on the main menu. There's an option button that maps to an enum for your multiplayer backend. Same button, same lobby, a different plug. Now, when we host a game, we have one button with two different backends. You can see, hit the button. I'm creating a peer, and from that peer, I'm going to create a server. That server is on port 7777, which is default, and its max size is 4 players. But with Steam, we're not actually creating a server. We are requesting a lobby from Steam. That's going to then come back to us with the lobby created signal that we're going to hook onto in the next slide. Joining with eNet, we have to provide the IP address of the host from the previous button using create client. And then we have to wait for a sync of the player data before we move into the next scene. That is done via RPC, which we will talk about next. With Steam lobbies, it's a little different. We're going to hit this button, sorry. First, host with a lobby. Using the same multiplayer peer we had previously talked about, we're going to allow other players to connect to this. We're going to set some metadata about the lobby name, and we're going to tag it so we don't see the 50,000 other Space War games. And then we're going to allow peer-to-peer packet relay, so if any connection fails, Valve can relay the traffic. Joining a Steam lobby is a little different. So first, we're going to connect to lobby. We're going to assign that peer, wait for the sync similarly, and then we're going to change the scene. Very similar to eNet. The big difference, though, is as a host, you are also a client on Steam. You connect to your own lobby. So on line 95, we're just going to do a quick check. If we are ourselves and we are the host, we're just going to move on to the next state. So who is who? There's a big difference between peer ID and a Steam ID. 2 different systems for your game. The big thing is on Godot, you have a randomized integer. You have your multiplayer.getUniqueID helper. 1 is always the host. Anything above 1 will always be a client. This is assigned at connection and forgotten at disconnection. It's how we target an RPC. It's how we name our nodes. It's how we set who owns what in authority. The peer ID is your seat at the bar. Your Steam ID is your account. It's a 64-bit globally unique ID. It's permanent. And it's your persona, your avatar, your friends, your lobbies, and the ownership. Think of it like a passport. Now, in action, we're going to get our unique ID. This will set who we are. Then we're going to do a quick check. By default, a player name is our peer ID. But if Steam is here, we're going to override the player name with the user's Steam name. Then we're going to send to the server all of our information on who we are. This is through an RPC call with an ID targeting the host, number 1. So who called this RPC? Who are we getting this information from? First, we do get remote sender ID. That is who fired this off. This is the peer ID of whoever invoked the RPC, and don't trust anything for any peer. Always validate and verify. Then we're going to send back to the sender the list of all players. This is that player sync I spoke of previously. If there's 3 people in a lobby and you're the 4th, you need to know about the other 2 who aren't the host. Go ahead and hit it. So our players dictionary is keyed by our peer ID. The gameplay that we're going to work on speaks in peers. But our name is coming from Steam. That is the identity a person put in their persona profile. The RPC with no ID is a broadcast to tell everyone, The label follows the player to every scene. So who does this mapping? The Steam multiplayer peer has two helper functions to translate your peer ID to a Steam ID and your Steam ID to your peer ID. In game logic, I speak RPCs for peer ID, but Steam delivers packets over Steam ID. We have zero custom mapping in this code base. Now that we're connected, it's time to start talking to each other. The anatomy of an RPC call is simply putting properties above a function name. Who calls it? The authority or the peer. Anyone can run this. Where does it run? On others or also on myself. And how does it send? Reliable, unreliable, or unreliable ordered. Now the big difference between reliable and unreliable, a reliable packet is like receiving a delivery that requires a signature. It's good for infections, scores, round changes, anything that requires for the gameplay to process. It's got TCP energy, but it's still UDP underneath. Unreliable is like a delivery person having a bad day who you're watching a Ring video for. It's the positions, the synchronizers, the entire job, stuff like particles, sounds, cosmetic effects. If something goes missing, we have another one sent right behind it. For state, can you go back one? Sorry. For a state, I try to consider it reliable. For a stream, constantly updating data, it's best unreliable. Now we're going to talk about readying up. In Cooties, you have a state where you enter a lobby. Once all players are ready, the game will begin. On the left side, we have, go ahead and hit, sort of a process to raise your hand, right? We're going to set ready. We're going to send it to every peer, and then we're going to call local on the sender. And then the starting gun is every player is checking for the ready, but only the server is telling players to change scenes. So the ready up handshake looks like everyone connects to the lobby, which fires the multiplayer peer connected signal. I'm ready gets broadcast to every player, setting the RPC to true. Each peer then stores everyone's ready state. And once all hands are ready, the host fires the starting gun and changes the scene. Ready is any peer, but the start is authority. Nobody can move to the next scene until the peer, one, server, says go. Now that we've connected to the lobby, established, readied up, and gotten into the game, we need to spawn players. It's important to think about who owns what when it comes to this. Who has Cooties? What are the scores? What's the current timer? How do we spawn and despawn people? That's all on the server. Each player has their position and movement, their current animation, their sprite flip, and their name. Think of authority as who is writing the truth. Now, looking at the spawner wired up, this is a multiplayer spawner node that we are writing a custom script for. The first thing we're going to do is override the spawn function with a custom spawn function. Only the server is going to handle spawning, so we're going to gate it right off the bat. We're going to set the multiplayer, we also want to do this as a deferred call, so we wait for the scene to be ready before we start spawning. Then when we spawn a player, we're going to set the peer multiplayer authority to that person. This way, I own who I am, you own who you are, there's no mix-ups. A lot of problems I had early on was not gating this, so you get like, if I crouch, we all crouch. A big catch with the multiplayer spawner, do not add this node as a child. Return it so it gets synchronized and spawned properly. But wait, who's this? Oh, your friend who wasn't really paying attention in Discord now wants to play and you'll have to restart. So under the hood, there's a lot of information when we have a late joiner, right? We have to connect to the lobby. Every peer needs to hear about this new person coming in. That joiner needs to introduce themselves to the server. The server has to send the full roster and world state, what are players' scores, times, lives, etc. Then we can finally spawn in this player. In SurfsUp, all this is hidden behind a load screen, but it is something to be aware of. Everyone has to agree on who exists before anyone can spawn. How I'm handling it is late joining is just joining. Staying in sync. It's important to think about what you need to synchronize. Things like position and rotation, animation state and sprite flip, anything that's continuously sending. A synchronizer is great for streams, but if we want events, things like one-shots or calculated values, scores, we want to send that as an RPC instead. Setting up a multiplayer synchronizer node allows you to take properties of a node to synchronize to other peers. This is all built into Godot, and in Cooties, we're going to set up the player position to always sync, the animation to always sync, and the sprite flip to always sync. But our player name will only sync when it's changed. Always will stream every tick, so drops are fine, but on change will send reliably, so you never want to use it for things like position or rotation. You end up sending more data than you need to. So it's important to respect people's authority. As I was previously saying, make sure you have this quick gate to stop others from processing if you don't own it. Things like UI, inputs, characters, all of that should be gated so only I can change it, but the synchronizer will send it to you. But we often have the jitter problem. Godot's network tick is hard-coded to 30 hertz, but your monitor will draw at about 60. Without help, remote players will teleport and kind of stutter. There's a really quick way to hack around this. If I'm not the owner, I just enable physics interpolation, and all of my movement is on the physics engine. There's plenty of other ways, from lerping to interpolation to extrapolation to Catmull-Rom sort of algorithms. There's 100 ways to fix this problem. This is kind of the cheapest one I found. You can go to the next slide. Also, I had a bug with Cooties originally. If a player would Goomba stomp another player, kind of get on their head like Mario, when the bottom player jumped, it would just send that top player flying. This is an issue with Godot's physics. It's a little cryptid. It has some weird kind of quirks. And our fix is to use rapier physics. It's a drop-in replacement. It's deterministic. It's actively maintained. The entire migration is you install an add-on and switch a drop-down. It really helped a lot. And there is no jolt for 2D, which is why we went with Rapier. And I'm also working on porting Box 3D, the new physics engine, into Godot. Similar to Jolt, it is just a drop-in replacement. I only spent like 2 days on it for a weekend. I could really use help. If anyone's interested in physics code, please check that repo. So talking about jumping, right? We have this 100 millisecond delay. If I press jump, I move instantly. It feels great because I'm the authority of this node. The synchronizer is going to send my position over to the other peers. The server will then check for a collision and make a call whether or not there is someone catching Cooties. The server will then send back to players who's been infected. Input to infection is about 100 milliseconds. You have to send it there, wait for the server logic, who has to send it back. But just something to consider. Everything is now a two-way communication. I am sending, I am receiving, I am talking to the server. So 5 things to take away from what we've done here. The multiplayer peer, one property, any backend, eNet, Steam, whatever you want to use. An RPC, who, where, and how are we sending this data? The multiplayer spawner, how to override it and how to spawn things into the scene. The synchronizer, what we're sending across the wire to synchronize states. And gating by multiplayer authority. I just want to give a quick shout out to my wife, Karina. I used Reveal.js for this presentation. Big shout out to the Godot Discord server, who I couldn't do any of this without, and Nerdiful, who helped me work on SurfsUp, Fryer Truck for the multiplayer peer, Swan for the booth, Boo Travier, OP New Player, everyone here at GodotCon, and everyone who contributes to Godot. Here you go. One more slide. And hey, go catch Cooties. Thank you all. Anyone have any questions? Yes.
As a quick aside, would you be willing to make this slideshow available too? It was a lot of information. It would be nice to go through this as well.
Thank you for reminding me. This slideshow is in the README of Cooties. So if you go to the website, there's a click link. It's like 2 days out of date because I haven't updated, but it's all this information.
Thank you so much.
Thank you. They asked if the slideshow is available. Yes.
Is it possible for like cross-platform for like someone using eNet multiplayer to connect to a Steam lobby?
That gets a little tricky. So is it possible to cross-platform, use eNet and Steam as different backends for the same client? As of now, I don't think that's an option. You could potentially, because where's the bridge between the peers, right? So I think it's got to be whatever your backend is, your peer is.
You mentioned that the kind of request to response time is about 100 milliseconds.
Roughly, yeah.
Are there ways that you can reasonably optimize that without digging deep into Godot's code?
So someone asked, is there a way to lower the response time? And yes, there's plenty of ways to handle it. I wrote my own synchronizer for SurfsUp v2. So we do stuff where, we're basically doing unreliable orders, but we're not sending if there's nothing to send. So like if a player doesn't hit anything, we don't need to do any input. And that's the best part about Godot, is you can go deep into any of this, whether it's in the GD script or the C++, you could really optimize and make it work for you. You're in the back.
Yeah. Are there certain types of multiplayer games that aren't a good fit for Steam's peer-to-peer?
Someone asked, are there any game types that aren't a good fit for Steam's peer-to-peer? And not that I'm aware of. It's really just doing the networking for you. So as long, basically, as you can build it in Godot, you can make it multiplayer. There's a lot of design decisions you have to think about, like, hey, if we're in a cutscene, who controls the dialogue? Or when we're making decisions, is that individually, as a group, et cetera? But it's more on the design side than the development side. Yes?
If you're not using Steam's backend and a player disconnects and they reconnect, is their ID still the same, or will they get assigned a new one? And how do you resync them in the session?
So someone asked, if you're using Steam and a player disconnects and reconnects, how do you...
if you're not using
Steam, how do you persist their data? You need to have some sort of account information on the back end. So how I handle it in SurfsUp, we have peer IDs, and then we do your scores based on your Steam ID. So if a player disconnects and comes back in, it's still the same Steam ID, it pulls back the same info. Yes?
I want to add that if you're using Steam Peer-to-Peer Relay, you are bandwidth limited. And so that may be a concern for a design thing around Steam multiplayer.
Fantastic. So someone brought up that if you're using Steam peer-to-peer relay, you may be bandwidth limited. How it's set up is it is meant to be a fallback, not the primary way to connect, but completely understand that. Yes?
This might be beyond the scope of this, but as far as persistent stats across play sessions, is that something that you would store individually on people's machines, or?
So someone asked if we have persistent stats across play sessions, how should we store that? And the big answer is you can do it anyway, right? So I leverage Steam leaderboards for a lot of stuff, and Steam leaderboards has details, so you can put whatever you want in the details of a score. I also have SurfsUp.website, which does global rankings and player profiles and map clears, and then the website runs a cron job to ingest all the Steam leaderboards every 6 hours. And you can also, Steam has a stats sort of API, and you could start adding stuff to player profiles as a stat and fetch it that way. So whatever works for whatever you're working on. Yes?
Is there a big difference in your approach for local multiplayer versus online multiplayer?
Yeah, I haven't really done local multiplayer. I don't have many friends to play with. So I haven't really touched that whatsoever, but it is essentially mapping different inputs. I know someone was talking about they have a local multiplayer game that can also go online, which, awesome. Yes?
How would you handle, say, there were multiple scenes in your game and one player transitioned to the scene? Would it load on everybody's?
That's a great question. So if there's multiple players across multiple scenes, right?
Yes.
So how I handle it in some other games I've done is I have the server, so these are all dedicated servers at this point, right? I'm handling instancing, and you can do that on peer-to-peer. But the scene tree has here's the zone, and then the zone has the overland, and then the overland has a dungeon. So it's this massive scene tree, and then I'm toggling stuff on and off depending on your current state. The big issue with that is you have to worry about, I don't need your data if you're in the dungeon and I'm in the overworld.
Right.
And the multiplayer synchronizer has a thing called visibility. So if I can't see you, we're not synchronizing. So what I end up doing is sending an RPC to toggle off visibility for players that aren't in my area.
Okay.
Does that make sense?
Yep.
Great.
Thank you.
You're welcome. Anyone else? Yes?
Have you hit any
technical limitations with Godot when you scale the player count up to maybe like 8, 12 players?
So specifically with the multiplayer spawner stuff, because the spawn packet isn't always resent if it fails, once you get around like 24 players, it kind of starts to buckle. My solution to that is I've rewrote the spawner for SurfsUp v2, so we're handling it instead of Godot handling it, and we're doing all reliable resending packets. I'm sorry, I had another thought, but I forgot it.
Thanks.
Yes.
What's a good packet size of information to be sending like consistently with the stream stuff? Like, have you found like a certain like over amount of like size like flags out the game or not?
Not the game. You're limited to 1,500 MTU for the network bandwidth. To remember what I was talking about there is a hard limit of 4,905 clients connected to a Godot server, and that's just the max value. So in my MMO Quake game, that was an issue when I was simulating bots. And to come back to you, how I'm handling it in Survivalscape, which is my roguelike I just added multiplayer to. It worked fine. I got the prototype up and running in like 5 hours, and then we had to unsingle player the game. Because there's a bunch of optimizations for like, if an enemy's not on screen, don't animate it, but we may not be on screen together. The big solution was I'm now chunking packets. So when the game starts scaling to like 700, 1,000 enemies, I was hitting the MTU limit. And I was lagging on my own PC locally to myself because I'm resending packets. So what I'm doing is taking the big array and I'm separating it. So I send just enemies, just attacks, just upgrades, just crystals across the 3 different ticks. And I'm doing it, just kind of splitting a third of the array each time. So in 3 updates, you're receiving all the information you need, and players know no difference. Survivalscape was a really difficult game to add multiplayer to, specifically for the single player optimizations, and trying to make it feel good when there's latency, which is still a bit of a problem. But how I solved it was you as a client are just sending me inputs. Me as the server, I'm simulating all the game. So I'm doing the processing of attack based on where you are, then RPC what the attack looks like. So it seems fine, it plays fine, but all you're really doing is pressing buttons. There's no logic on your end. Okay, final question, anyone? All right, thank you all very much for being here. I really appreciate it.